Okay, here we are looking at another pump installation. Let's just get started right away. Electrical tape wrapped around leaking unions is not going to fix a leaking union. We got a halfway decent manifold here, some ball valves, some older single unions missing. The handle's not a big deal because you can just grab that handle and stick it on here when you need to turn it. And we got a better quality dual union there. Glue job looks a little bit sloppy. As you can see, that's not what it's supposed to look like, but that's okay. Let's see, that looks like Teflon and silicone. Silicone for the suction side connection. And we're going to come out here, you see right away, you've got one half of an offline chlorinator connected there. Got a bunch more electrical tape, which is again not going to solve any kind of problems that you might have. Here's that offline chlorinator. So our spa flex line comes out of the pump, into the filter, out of the filter, and we got a couple back-to-back elbows here. Back-to-back fittings is never a good idea. It compounds the decrease in flow that you get. So at least these are the right sweep. It's not a full sweep, but it's not a street elbow either. But having two back-to-back like that, not so great. I would have preferred to see maybe double 45s there, because that's going to be a lot less of a flow restriction. So then we're looking at these reducer bushings. These here, that gray that you see, that's CPVC. You might have seen that on some of my other videos. I talk about how that's not required in the area I work in. But my preference is to have 3 feet CPVC in and out of every heater. These little nipples here, about 8 inches long, they come with the heater. That's why we see them used occasionally. So coming out of the heater, we have a street elbow now into a reducing bushing. They did that instead of having a regular sweep elbow and then having a reducer bushing there. I mean, it's easier because you have one less cut to make from an installer's point of view, but to have a sweep elbow here coming right out of the heater is going to be a huge detriment to the flow dynamics of the system, as is this one right here. So now we've got 2 street elbows in pretty close succession there. Not what I want to see at all. So here's the biggest complaint I have in this room. Here's the outlet port on that offline chlorinator. So there's a difference in pressure experience between where it starts here and where it connects here, because it's on opposite sides of the filter. The filter creates a difference in pressure, and that differential pressure is what draws the chlorine from this feeder into the system. The problem I have is anytime that you're injecting chlorine into the system, you need a check valve here. Like, these heaters are super expensive and they cannot take concentrated chlorine. That's the same reason why you shouldn't put chlorine pucks into your, the pump skimmer basket here, or into the skimmer basket for the pool, because then you're drawing concentrated chlorine into the pool. So in this sense here, this chlorine feeder is feeding chlorine in right here, but that's going to backtrack through the system. Anytime the system's shut off, you're going to have the concentrated chlorine leaking out, and this header right here is going to rust out for sure. There's no doubt about it. This heater will last half the length of time it should without that check valve installed there. And further compounding that, here is our bonding lug with nothing connected to it. This heater is not bonded. Here is our bonding lug on the pump, not bonded. What that allows for is a difference in electrical potential between this piece of metal and this piece of metal. We might just be talking theory here, but the reality is that galvanic corrosion is something that will damage your swimming pool, and bonding the equipment keeps all of the metal components of the pool, whether it's this heater or this pump or the walls in this pool or the bracket for that diving board there, everything should be connected with a number 6 bonding wire, bare copper bonding wire, to draw everything to the same electrical potential. And then you ground that bonding grid, so that makes every metal component in the pool the same, and then makes that equal to 0 potential, because it would be connected via ground wire to the ground of the house. So it's a little bit complicated. One of the more complicated subjects that we talk about is bonding versus grounding, and how that relates to galvanic corrosion in your swimming pool. It's not just a saltwater pool problem, although it is more pronounced in a saltwater pool since your salt levels are much higher. A regular chlorine pool, a couple hundred parts per million. A saltwater chlorine pool, maybe 3,000 to 4,000 parts per million on average of sodium. So the more salt that you have, the more galvanic corrosion that you're going to have, and the more important it is to be bonding your equipment to prevent any small currents from traveling in between different metal components of the pool.